So I don't know if I succeeded to do full screen. Do you see still the slides?
We do, yes.
Okay. So I will speak even on behalf of Stefan. I haven't checked if he's connected, but we have
Yes,
to.
I'm here.
Oh, okay. So Stefan, you can comment at the end of my presentation. I will try to be short in the presentation. This is the section concerning the design of the vacuum and the cryogenic system for the Einstein telescope. This is one of the main challenges that we have in this new detector. In particular, as I will tell you, vacuum is in practice the second large cost in the budget. So it's one of the most important systems that we have to deal with. And then cryogenics for the community of the people involved in the ferrometric detection of gravitational waves is a news apart from the experience that is underway in Japan with our Kagra colleagues. So this is a section that we are trying to organize to start this activity from the beginning of 2021. So you have already seen probably several times this picture in which we show this triangular shape with the high frequency and low frequency interferometers is in an impressive numbers of vacuum tubes and cryogenic system to be developed in this design. So let me speak try to figure out a bit the situation in for vacuum for vacuum and then for which concerns the cryogenic systems. For which concerns vacuum, we have to deal with high vacuum system and ultra vacuum system. They are needed for several different reasons. The people that are involved in this experiment since a while knows very well. We need to reduce the noise due to the vacuum fluctuation along the bit path. We need to isolate the test masses, reduce the test mass motion excitation due to the residual gas, reduce the friction or losses in the microsuspension, contribute to preserve the cleanness of the optical elements. This is one of the main reasons that needs for the vacuum. And vacuum system, ultra vacuum system in ET means to design a system with almost 120 kilometers of ultra vacuum pipes with a total pressure, total residual pressure of about 110 to minus 10 millibar, corresponding to something which is of the order of 10 to minus 2014. Oh, sorry, I did a mistake. 10 to minus 25 of square root hertz as residual noise. And a hydrocarbon partial pressure should be at the level of 10 to minus 14 millibar. There are tens of vertical vacuum towers hosting the optical elements. This includes the lower part and upper part of the towers, similar to the Virgo design. In the case of low frequency RF, LF, the tower basements are cryostats, while in the case of HF are ultra vacuum chambers. So the vacuum pipes should be equipped with baffles, as we did in Virgo in all the interferometric detectors. So even in the 3G detectors, we have to install baffles along the pipelines, and we need to ensure during the installation and during the operation the absolute cleanness with no residual particle dust along the light path. This is a picture, an old picture of an old sketch that is showing the nested configuration of LF and NF, LF, HF, HF tower. And this implies even a certain complexity in the configuration, the final configuration, the design of the final configuration, and constraint in the even in the installation of the various tubes. So
Fulvio, we don't see the full screen anymore.
I don't understand what is doing this kind of.
In any case, don't worry. You can just now it's fine.
No, okay. So this is an idea of an old sketch, even another old sketch of that gives an idea of the configuration of the various towers, the huge number of towers that must be designed, built, and installed into the underground area. So this is just to give you a quick look of how much is complex. It's at the level of complexity of this design. This is another sketch, the one of potential possible configuration for installing the 4 tubes that we have to install in the gallery with the HF and low F interferometers. This, by the way, this is a bit out of scale because the indication that we received is to decrease the diameter of the gallery and install tubes that has a diameter which is of the order of magnitude of a diameter with an order of magnitude of 1 meter for each tube. See, this is the order of magnitude. And while for the galleries, we are ranging around a diameter which is of the order of 6.5 meters to reduce the cost. So one of the main issues that we will have is also to define the installation procedures and the tools to be developed for the installation of such tubes inside. For sending cryogenics, this is, as I said, is a new issue for Virgo and LIGO, not new for CAGRA. The idea is to cool the mirror at cryogenic temperature. That means in the range of, at least at the beginning, in the range of 20 Kelvin. The difficulty is that we have to cool the mirror in practice without touching it. The extraction of the refrigeration power should be mainly done through the 4 wires, the 4 suspension wires, the 4 suspension fibers that must be relatively thin, because otherwise we can spoil the dilution factor for the thermal noise. So here there is the problem of the detector cooling, the problem of the mirror cooling is strongly interlaced with the development of the cryo payload, at least for LF. So this is something that must be studied, and the way in which we have to cool down the mirror must be studied in parallel with the development of the cryogenic payload. The main goal is to cool down the mirror without introducing extra vibration noise. This is must be stressed at all times, because when you are introducing cryogenics, you are introducing an extra noise of source. This is something that the people, the few people that were involved in the old adventure of cooling down the resonant bars for detection of gravitational waves knows very, very well. And this is one of the main points here in the case of the interferometer, because in this case we have a broadband detector. So it's much more important, much more delicate, this aspect. And we need to ensure that the cool down is done with a power, a refrigeration power that permits to extract the heat, the residual heat absorbed by the mirror residual heat, which is in part due to the residual thermal input in the cryostat, and a relevant fraction of this heat comes from the absorption of the light that is used to, which is pumped into the interferometer. So the order of magnitude should be lower than 1 watt. The order of magnitude of the residual heat should be below 1 watt, but in my opinion, it's better to have in mind this number, not 100 milliwatt, as I heard in several times by different people. It's better to stay with a rather large safety margin, because it's better to provide enough refrigeration power in the worst conditions. Then now what we are doing is to try to develop the system following the technology that is applied in Cagra. So a technology based on cryocoolers, the use of cryocoolers, which give less problem even from the point of view of the maintenance, lower cost, and from the point of view of the safety system in the gallery, in the underground area. The typical problem of the cryocooler is that these are objects which vibrate. So we have to be very careful in trying to screen the vibration that can propagate and spoil the performances of the interferometer, and the event can spoil the silence in the underground area. So one of the main aspects is to define well the anti-vibration path for the X extraction, and optimize the fiber thickness and the length of the fibers, as I said, in order to not to spoil the thermal noise limit that we have to achieve. The alternative system for PT cryocoolers is to use cryogenic fluids. There is an effort to develop a system based on the use of helium-2. There are a lot of advantages if we are using superfluid helium. The first main advantage is the fact that potentially we can extract a lot of more, we have much more refrigeration power available, so we can cool down the mirror at lower temperature. But even the second main important aspect is the fact that this system can be designed in such a way not to generate any vibration. So the other side of the coin is the fact that this requires a cryogenic infrastructure on surface. We need to design the transfer lines. You need to define better a safety plan when we are using cryofluids in an underground area. So there are several points that must be clarified, designed, and studied. And this requires also a certain level of R&D development, a very interesting R&D development, but this is needed. Then, in addition,
you have a couple of minutes.
Okay. In addition, we have to design also the long radiation traps to stop the thermal input on the mirror, which coming from the long pipelines. Here there are some sketches that shows the general idea that we have to design for the cooling of the LF in cryogenics. But let me end the talk just by presenting the structure of the work packages. We have defined 5 work packages on vacuum and cryogenics. So the first one is devoted to tower power, the second one to the vacuum pipe arms, the third to cryostat and cryopumps, and then we have the fourth devoted to cryogenic infrastructure, the fifth of detector cooling. there are several people from different institutions that expressed their interest, that want to help and give a significant contribution on these specific work packages. All of you are welcome. We need your help. This is my message. Okay, I end here.
Thank you, Fulvio. Thank you very much. Interesting talk. We have time for a couple of questions. I see one question from Harald in the chat. What about sorption cooler?
Even in this case, in my opinion, even in this case, can be classified an R&D activity, because we need to develop a specific absorption cooler that permits us to have enough refrigeration power. It's a silent system, but we need to demonstrate that can provide with continuity, because we need a high duty cycle, the high refrigeration power. So this is one of the aspects that could be explored. By the way, the idea that we have in this work package is to try to give our contribution in setting up a new chapter of the design of this detector, but the second outcome should be a definition of a coherent R&D plan, because in my opinion, if we want to advance, we need to have a coherent R&D plan, just because in this way we can drive this search without wasting resources, and not to have overlap, significant overlap on the same problem.
Probably Stefan would like to comment.
Yeah, no, I just want to add that we have two interesting talks tomorrow in the afternoon session. There will be one talk on the helium-2 cooling system, and there will be also a talk on cryo pumping. So where we are already starting some specific design details. Yeah.
Yeah. Thank you, Stefan. Yes, indeed. Tomorrow the instrument science session will continue, and maybe at the end of the day we'll give you some more details. Any more questions for Fulvio? Michal.
I have a question about what is the interaction between cryogenics and vacuum. So what are the requirements on the vacuum so that there is, for instance, no frosting at the mirrors, as Kagra has issue with that at the beginning?
Michal, you asked questions that require to show the rest, the other 10 slides that I haven't shown. So there are a lot of interaction. In the other slides, there is the list of the charge of each section of this work package with the interaction with the other systems. And there is also a list of other issues that we have to face. For example, the problem of cryostat connection with the upper part of the ultra-high vacuum. There are the problem of cryostat connection with kilometers pipelines. There is the problem of cooling down procedure and reduction of the cooling time downtime, because this is important to avoid the reduction of the duty cycle of the detector. There is the problem of condensation on the mirror surface. This is a point that has been already, is a problem that they have to face in Kagra already. And there is the problem of defining which kind of super insulation we have to use in the cryostat, because if you are using the standard aluminized mylar, which absorbs a lot of water and typically is not so clean, we have the problem with the mirror cleanness. So this is just a not exhaustive list of other issues that we have to face, and this is but gives you an idea of the huge number of interaction of gray areas that we have to share with other divisions.
Yeah, and also where new ideas and contributions are welcome. By the way, I think that tomorrow one of the talks, the talk by Roberto Cimino from INFN Frascati, will shortly address the specific problem of decondensation on the mirror surface. Yeah. So we'll listen tomorrow. So let's thank Fulvio and Stefan again. Let's move forward to the last talk about the ISB divisions, infrastructure division. Who is going to talk? Maria. Yes, we can see your desktop.
Okay, so I'll start.
And we hear you as well.
Okay, very good. So I'm here again. Unfortunately, Florian couldn't attend this session, so I'm speaking on behalf of Florian as well. And just to describe you how we have organized our activity inside the division number 6 of the ISB, that is the last one, but not the least. Actually, is a little bit different from the other one, because we are not talking about science and experimental physics. We are talking about infrastructure. So we had some minor problem in collecting the community of scientists and researchers to work around this topic. Even though there is a large interest, it's difficult to explain which is our role right now. As far as we have understood, in this division we have to collect all the requirements from the scientific community in order to provide some indication, some guidelines for future preliminary design of the infrastructure. This means that we have to start to study, as you have seen before from different presentation, to study the site condition, to study the possible engineering solutions, different scenarios for building up the interferometer, and try to make them as much as feasible as we can, in order to go in the further step for the contracting and consulting and really engineering stuff that will start soon. So me and Florian, we have divided our activity in 5 working group. One is, of course, the first two are, of course, the first one is the main one, of course, is dealing with the underground works. In terms, I will show you some example. You have already seen in different presentation the activity, the ideas that is already prepared, as already under investigation. And but we also decided to split the activity also in different topic, different task, in order to be more specific on different issues that are very relevant also for the infrastructure. And for this reason, we have find people that can work specifically on the surface infrastructure, meaning that the surface lab, but not also the surface lab, also the all the buildings that are serving the underground infrastructure that has different problems to be solved, not the for example, not the geological, geotechnical problems, but more the environmental problems to be addressed. And also we also prepared a group, we set up a group for safety, to take care of safety issues, and one focused on service plans, meaning the mechanical, electrical and telecommunication plants that should serve the infrastructure. And the last but not least group will deal with the regulatory framework in terms of legislation and rules, and dealing with the permission steps that should be faced before starting with even with the design phases, and of course after during the construction. So the infrastructure. I don't see my screen. Okay. I have a different. Sorry. So the infrastructure will deal with, of course, with all the works that include that are needed for the construction of the interferometer underground, meaning to collect information from the geological study, geophysical studies, geotechnical analysis, to go deeper into the excavation methods that can be used, also face the groundwater drainage problems, the geometry of the cavern, the tunnels and the access to the tunnels, how you can go, which different solution can you find for the access. I will show you some slides that Florian also has already shown to you, just to talk about some specific problem that should be faced. For example, the excavation of some large cavern could be made by finding the solution starting from the top and going to down in order to reduce the risk of people working in the gallery, and then you have to decide in which the tunnel should be excavated in terms of orientation, considering the condition of the rocks, the characterization of the rocks. You should also we should also understand which is the optimal geometrical configuration. Of course, this activity will be done in parallel, will be done generally speaking, but also in parallel with the looking at the site specification. And then another issue that we should face is also discuss with the expert which are the best excavation methods. We have talked about TBM, regular TBM, we have talked about blasting. We should see how this different method can influence the time and the cost for the construction of the infrastructure, and which are the best method for to guarantee the accuracy in the excavation. Florian was talking about using gyroscope control TBM. There are specific instrument, specific machine that can be used and can be defined in order to maintain some specific requirement of accuracy during the construction. This is another tool that we'll for sure use with the geotechnical expert that will join the group to do some modeling in order to find which is the different configuration, which are the technical solution that can be applied both for the excavation phase and also for the reinforcement. And we have also talked about the geological and geotechnical study that are has been carried out in the different sites. We will put together all the experience and to understand which are the investigation and the analysis that should be done, and in order to proceed to present the results to the site preparation board that will be analyzing our outcomes. Also, we also will look after the drilling activity. You know that both in Limburg and in Sardinia there are activities in going into this direction. In Limburg there are 5 boreholes that are have been decided, have been realized in this period, and we have also starting in Sardinia with 2 boreholes. In both cases there are data that will be collected and shared in the community to compare and to understand the different site characteristics. And another activity is linked to the surface investigation. Let's say mainly the activity that can be done with the using performing geophysical prospection. Florian talked to you about a large campaign that is starting in Limburg. We in Sardinia we also have set up in January. We will start with a small size campaign around the place where we are starting to drill the borehole, and but of course, and in the meantime we are also preparing a general plan for larger campaign at the site. And another issue that should be faced is that of the water management. It was tackled in many in different presentation during the meeting, and this can is as you know, is a critical issue that can be solved in different way, and of course it's very dependent on the site, on the rock characteristics, and on the morphology also, because you can find different solution for dewatering the tunnels, and first you have to quantify the amount of water that can be produced. So there are some preliminary studies that should be done in order to find possible solution, different techniques to face this problem. And also this is also apply for the access tunnel that can be different geometric configuration. As a service infrastructure, we are collecting information within the scientific and the technical community in order to provide right dimension to the building that should serve the underground infrastructure, and also doing some preliminary decide some preliminary requirement for the location, a proper location of this building, in proximity of the vertex, in proximity of the access. It depends on the this will be also analyzed during our activity. The last three groups will in the surface infrastructure group, we will also involve some experts in innovative solution for optimizing the space underground, for monitoring the conditions underground. So we will use a lot virtual design and optimization tool for planning, at least at very preliminary configuration, the building and the space underground. On the safety issue, we also involve experts that will help us in identify the right materials and the right solution for reducing risk in the lab, in the tunnel underground, but also on the surface. As the
3 minutes, Maria.
Okay, I'm finished. As far as the service plan plans, we should, as you know, the two possible sites are completely different. One is in a very served area, in a very urbanized area with all the service, at least close to the site. In Sardinia, we are in a very remote area, so the problem to face are completely different ones. But in any case, there will be a need to connect the interferometer with existing networks, to implement, to start additional energy for running the instrument. So this is something that should be at least quantify, and also solution for finding these resources should be figured out. And the last one, another issue that we we should tackle, I told you, is the problem of legislation, of understanding if we are touching some protected areas, we should consider some constraints, some environmental constraints. So, and also we should also understand in which way we can have the access and the right to build some infrastructure in the different place. So we have set up a group for this. Last things I want to say, all the information that we will gather in this working group that are mostly geographically based, because they rely with geology and environments and all results, outcomes from the investigation, from the analysis, in situ analysis. We will organize a GIS project, probably a web based that will be available for the community to share the data and all the information that we will collect. And this can be done for both sides in order to be to allow everybody to have access to our activity. This will be integrated with a BIM model that is mostly dedicated to the infrastructure 3D modeling. Okay, I think I have, this is all for me.
Thank you, Maria. Thank you very much. Very impressive job. Any questions or comments for Maria? There were also already discussions yesterday and this morning about the site-related infrastructure, so probably. Okay, if not, let's thank Maria again. Let's move ahead. The last two talks of the sessions will be devoted to description to the community, to two relatively new initiatives for R&D, one based in the Netherlands, in Maastricht, the other one in Sardinia. The first one to talk will be Stefan Hild, Maastricht University. Stefan, I see you're ready. We see your slides. Please go ahead.
Yeah, okay. Good afternoon. Thank you very much for the opportunity to talk here about ET Pathfinder in this session. And I should say I'm obviously talking for kind of a biggish team or moderately big team. I will not go through all of the institutions here, but you see here kind of the 15 founding institutions at the beginning, and then after this plus here, you see all of the institutions which have joined recently. Okay. Oops, how do I get to the next one? The outline is I will talk a little bit about ET Pathfinder, give you an overview, what are the aims. I will then go a little bit into some examples of the R&D we really want to address, and then talk a little bit about the current status and plans for the future. I guess I don't need to talk much about this. I think we are all aware, and we have seen yesterday, there's some absolutely amazing and fantastic science to be gained with ET, and to which we are all looking forward. But as we have seen in many of the talks today, there's also quite a lot of challenges, between us and this amazing science. So really, we have to work a lot before we get the fruits of ET out. And there's no secret, it was already mentioned in various talks today. There's this big difference between the low frequency, where you have to gain these orders or many orders of magnitudes in sensitivity, compared to the high frequency part, where we have more or less control, good understanding of the noise sources, and you need to improve by less than an order of magnitude. So for these fundamental changes here, you know, to improve these orders of a million, you might need new technologies. We mentioned them, cryogenics and so on. And these we really need to test, to demonstrate, to engineer, you know, learn to work with these, you know, catch up with 40 years of what we have done with LIGO and Virgo and before with the prototypes. And this is really where we hope that ET Pathfinder can play a role. So what's the aim of ET Pathfinder? It's really to provide a prototype, a low phase noise prototype with moderately easy access and moderately fast turnaround so that we can test technologies for ET. And the key is really kind of a prototype where we want to test things at low phase noise, so really kind of, you know, at 10 to minus 80 meters or equivalent, and at a system level. So for sure, you know, any new fancy coating will be tested, you know, first in a small coating measurement setup. You know, you might have cooling things you test on dummy mirrors and so on, but then you don't know, you know, how quiet is your system really. So I think you have to put it into a full interferometer to really understand what you get out there, but also to really learn about the dependencies and the interplay of these different subsystems. And that's what we want to do. The whole prototype is more or less set up around 4 cryostats, which can in principle hold ET-like test masses. But as we don't have these big test masses right now, we will run it initially with small mirrors. Small means 15 centimeter mirrors, and explore the full matrix of, you know, ET, but also kind of, we heard 2 days ago about Cosmic Explorer and Voyager also going for cryogenics. So the whole matrix of temperatures and wavelengths. And here you see a picture how you can do this. Initially, the cryostats are big enough that you can always fit 2 ITMs and 2 ETMs next to each other in the cryostat. And that then allows you, instead of having one big interferometer, you have 2 small Fabry-Perot microson interferometers, parallel arms here, and you can choose them to operate at different temperature. So I will show a little bit of a fancy Marco Kran movie of what ET Pathfinder looks like, just to talk in between a bit about what you see here. So as you see, it's a Fabry-Perot microson. We have 6 vacuum towers here. There's kind of 2 injection and output towers, table towers where you have suspended benches in there. And then you have here your 4 main mirror towers where you have actually the ITMs and the ETMs in there. Obviously, we want to go for silicon mirrors. We, as I said, have cryostats in here and cryogenic infrastructure to cool the mirrors down. And obviously, we want to use the new wavelengths. But also, I think an important part is not to forget the quantum noise reduction schemes, because I think there will be many things very different. You know, if you think about it, just giving one example, because of the higher absorption of your silicon, you might go for higher arm cavity finesse than we currently do. If you go for higher arm cavity finesse, then obviously that has some implications on, you know, your RSE strategy, also on the losses for the squeezing and so on. So really kind of, that's what I mean with the systems approach. You need to have all of these things together to really see how they work rather than thinking about individual subsystems. Okay, so that's the idea of ET Pathfinder. As I mentioned at the top, this was started by 15 universities and research institutes from the Netherlands, Belgium, and Germany. We got a grant of 14.5 million, about 4 million from Europe, and then the rest is from governments and institutions and so on, co-funding. And you see a nice side effect, just to mention, if you look at the list of these institutions there, many of them are actually kind of powerhouses in particle physics who now swap over partly to gravitational waves. So it's actually quite nice. And you see in some of them, through ET, they joined the field, but they are now also contributing to the current detectors and, you know, take up roles in Virgo and so on. So it's really nice to see how ET is a magnet, you know, for the gravitational wave community, and also helps increasing our efforts at the current detectors. And there are other institutes, and I'm very, very happy to say here is first one, Lab ANSI is a big help for ET Pathfinder, helping with the control and data system. And yeah, it would have been nice to have this meeting at ANSI actually and see the hardware that is built there and so on. There are other institutes like Albert Einstein Institute, Birmingham, KIT, and so on, which join. And I should really say here that our efforts are really kind of open to everyone. You know, the telecons are open and stuff like that. Quick to say, for the German side, they recently got some funding through, and these are the institutions involved in that, working towards ET and partly also to ET Pathfinder. And one, that's why I highlight this here, is kind of a nice link. That's a group of Benno Wilke, where this funding and additional funding for excellence clusters actually joined ET Pathfinder. They will provide a laser source, a pre-stabilized laser source for ET Pathfinder. Like any other project, the project obviously has some structure. I don't want to go too much into detail here, but just to mention two of these. There's down here in color, this is where all of the work happens. And we are very grateful that we have a stack up here with very knowledgeable people who have been project leader on big things, or are currently project leader on big things, or a science chair of the LSE and so on, involved in Kagra. So that has been very, very useful, and the advice we have cherished a lot, even though also it was quite a lot of work that we always get out of these stack meetings. And I don't want to dwell too much on this, but the nice thing is really kind of, that the stack really kind of is happy with us. They mentioned this is a unique facility, and it can become a very natural center for technical innovation and scientific breakthrough. So I think that gives us a motivation and a little bit of confidence that we are going in the right direction. I should mention a bit about the long-term plans. ET Pathfinder is a long-term activity. If you look at the S3 application, we operate from 2035 to 2085. Okay, so I mean, this really needs a bigger picture. We need to look far into the future, and obviously we expect many ET upgrades over the next 50 years. And I just added last minute this plot here, because that was a plot that Michele referred to, that I showed 2 years ago at the LSE meeting. And this is kind of the result of the ET design update workshop we did in 2017 in Glasgow, where I guess quite a few people were there from the current audience, and where we actually looked at this red line here. What is the facility limit? The dashed line here is ET. And obviously there's some space here, and hopefully, in 2040, 2050, we can, build new technology into ET and close this gap a little bit. And this is really kind of what is here in the red box. And for the ET Pathfinder timeline, the idea is really when you operate generation X, where X is larger than 3 in ET, then obviously you want to observe and don't disturb ET. But somewhere at the same time, you need to do the research and the development for generation X+1. And we hope that ET Pathfinder can play a role there. Good. So that's a big overview of ET Pathfinder. What are some of the examples of the R&D we want to do? What is the program at all about? We are currently setting up a clean room of 6,000 cubic meters. And just to show some fun, some features here, this clean room has 2 different foundations to separate kind of, all of the air conditioning noise and, the wind on the walls and so on from this quiet area here on the red foundation. We also put some effort in the tendering to find ways of separating kind of or get good acoustic isolation from special compartments like this green one here set up for noisy equipments like, pulse tube coolers, pumps, and things like that. The vacuum system we have seen consists of six towers, 2.8 meters diameter, a bit more than 6 meters tall, in total 130 cubic meters. And we aim for the total pressure to be 10 to minus 9 millibar, mainly also driven by the water, that we don't get ice layers on the mirrors, which was mentioned a few times. And this combined with that, obviously, we think compared to ET, we will have more frequent venting, so we will get more water in. And that's why we foresee to have regular bakeouts at, not the high temperature, but something like 70, 80, 90 centigrades before we switch on the cryogenics. Talking about cryogenics, we heard from Fulvi already kind of, all the background story, so I don't have to say much here. Here you see the design of a test mass with the marionetta here, and then the reference masses around it. And what we do is we bring in a coat finger here, and what we want to play with is kind of, how do you get the heat out of this coat finger? There are different solutions. Absorption coolers is what is currently our baseline. Pulse tube coolers, we know Kagra has already tested. And then there's, any combination of liquid, cryogenic liquids, and there will be a talk by Leonard tomorrow about helium-2 cooling. ET Pathfinder makes huge use, obviously, of liquid nitrogen to cool down heat shields. Okay, so this is obviously the cooling is one of the key parts. We want to reduce the water. Fulvio mentioned already, you don't want to have MLI in there. So what we have here is actually we use 3 pairs of shields. So these are just aluminum sheets, but a few hundred kilograms in total, which sit here on top of a liquid nitrogen vessel to cool the intermediate shield. And the inner one will be connected to a pulse tube cooler. And I think one of the interesting research topics is really, you see here how complex the heat budget is. Yeah? Each of these boxes refers to a certain kind of heat that you need to extract at a certain temperature. And obviously these come with very different requirements in terms of, how much noise coupling can I allow, for example, at the cold finger or one of these heat shields. So actually you can play with different combinations of all of these liquids, pulse tube coolers, absorption coolers, to see how do you extract all of these. And then one thing that obviously you shouldn't forget is how to do the cool down so that you get down there in time or in a reasonable time. For the ice layers, and I come back to that.
You have 2-3 minutes left.
Oh, okay. I thought I just started 12 minutes. Okay. Is actually that we don't have off-the-shelf simulations to trace the water in there. Okay, seismic isolation, I will jump over because that was covered already by Alessandro in detail. We are doing a little bit of laser development. We have now settled on 2090 nanometers for the second wavelengths. And obviously, we are now also developing quite a lot of the optics and coatings. So there's the main mirrors, as I said, 15 centimeters float zone. We will initially work with currently available coatings or amorphosilicon multi-material. But one of the initiatives is to have an MBE set up, a new one created at Leuven to explore crystalline coatings with various metal oxides in, which seem to be very promising. Good, so where are we? What's the current status? Again, I will not have time to talk through all of the details, but if you go to the ET TDS, you see there's quite a lot of documents here, and they are all open to ET, so have a look and there you can follow the stuff. We started in February this year with getting a haul from the university, which was more or less a furniture storage. We pulled out the concrete floor out there and made the new floor in there. I run a video just to see. So it was originally something which was consisting of 2 different halls. We pull the walls down here, take the old concrete floor out because it was not giving us enough stability and inertial mass. As I said, it was connected to the walls and things like that. And we put in a big slab, which is 0.5 meter thick. And the problem with that is you obviously want to not have it sink in and you want to have additional stability. So what was happening was actually we drilled about 170 poles in there. You see in a second, and these poles then actually hold the whole floor. So here you see they go with a certain grid of these poles. And then you see also there are these different kind of dilatations of the floor. And I stop this here for the sake of time. If you want to look at this, have a look at this YouTube video and you can see it. Good. I jump over these things that are technical details. This is what the current status is of the clean room. So this dirty hall with furniture, you see now has nice clean room walls. We are building this and we think in March this will be finished and we will get actually the first optical tables in there. Lots of work has happened on the vacuum system. I don't want to go too much into detail here. One interesting thing, because it connects to some of the topics that were mentioned earlier, is the water on the mirrors freezing. And as I said, there was no off-the-shelf simulation tool available. Henk-Jan Bolton wrote one himself. You see here was representing our system with about 300 simple geometries. And this was actually, his code was then actually tested in a test chamber at NICEF, which we also simulated, that fit into these simulations. And then we compared these versus COMSOL and MoFlow, and that actually gives us the confidence that we now understand how this individual tracing of individual water molecules actually works. Some of the prototypes become reality. This is one that was shown already by Alessandro. And I just want to come back to the point of getting new partners in. Here you see that's a one-to-one model of, or not model, it's a setup of our mirrors. And you see again, there are new universities in here, Brussels, RWTH, helping and building these things together. To jump over this, many other things are going on right now. As I said, one of the nice things is the lab system I would really like to focus on because of the occasion of the ET Symposium. And a nice side note is actually that ET Pathfinder helped to reduce the cost of Advanced Logo Plus by actually hooking onto these orders. So that's, I think, something good. Finally, takeaway messages. I think ET Pathfinder is a long-term initiative. And I think that's something I cannot stress more. It's completely independent of the site decision. It will not vanish after 2022, but will be there for decades for the ET community to use and exploit, having this facility. I think it's a huge opportunity to test vital and essential technology. And I think it's really necessary for us to increase our confidence in ET, but also the communities, and particularly the confidence of the funding agencies that we know what we do. And as I said, everybody is welcome to join. There's still lots of work which is not assigned yet, really subsystems where the money is there for the equipment, but we are lacking the manpower. So please get in contact and join the effort. And with that, I stop here. Thank you very much. And are there any questions?
Thank you, Stefan. Very interesting and impressive work indeed. Questions for Stefan? Let me look in the chat.
May I ask
Enrico, please, go ahead.
Hi, Stefan. Maybe you have already shown, but I lost a planning for the construction of ET Pathfinder. I mean, when you think to have the first results?
Yeah, that depends on what you call first results. So as I said, I think in April next year, so 3 or 4 months from now, the first optical tables can go into the finished clean room and we can work. We are currently, the tender for the vacuum system is currently open and companies bid against it. And, depending on what their delivery times is, which we will only know, I think the tender closes on the 6th of January, then we can do a more tight time planning for the vacuum system. So I would hope that, we would start getting in towers, after the summer, early autumn or something like this. And then, the real fun with the vacuum system starts. But it's, as I said, it's a big vacuum system. Obviously, also the cryogenics are quite big. So there are many things to do. But if you look at kind of, the whole project, as you know, there's quite a lot passing by before you really see stuff. I mean, from the project timeline, we are nearly at half of the project by now.
Sorry, can I ask you one question?
Sure, Fulvio.
Nice talk. Thank you for all this information. Concerning the mirror that is in preparation in Berlin, I missed information concerning the dimensions of this mirror. This is optical grade, I suppose, silicon optical grade. What are the dimensions?
So what currently is actually working on, as we speak, they are producing 2 ingots, which should allow us to get 12 ET Pathfinder mirrors out. They are 6-inch ingots, and the mirrors, as I said, we start with small mirrors, will be 15 centimeters in diameter. It's float zone, and the first tests have shown that the resistivity is larger than 14 kilo ohm centimeters. So that should be completely okay. I think we need to be larger than 10 kilo ohm centimeters to get into the ppm level of absorptions.
Thank you.
If there are no more questions for Stefan, let's thank him again and move ahead with the last talk of the day. Domenico, are you ready?
Hi, I'm here. Can you hear me?
Yes, very well.
Okay, let me try to share my screen. Let's see.
Yes.
Did you see the presentation?
Yes.
Okay.
Perfect.
So first of all, thanks for the opportunity to speak about the Sagrav Lab.
Musacchio, Marco. Eccolo là. Guarda lì.
It's not me. No. Okay. Thanks for the opportunity to speak about the Sagrav Lab. You have seen the Sagrav if you have been at the last ET Symposium in Sardinia last year. The point is that you have seen the studies at Sosenatos. Here in the map, you see that the plan for ET construction around the mine, around Sosenato, is the following. And the crucial point is that at Sosenatos, you have a former mine that allow you to access tunnels and underground with shaft and with miners that are still working there. And so you can benefit of all this structure and make measurements deep at different levels, and a benefit of the low noise present at the site, using the site as a lab for experiment. That's why the Regione Sardinia founded the laboratory to host that kind of experiment. So at the moment of the surface, you have more or less 900 square meters of surface available for equipments, with control room and optical lab. And there is in preparation an area of 100 square meters underground to host experiment. The first experiment that will be hosted is Archimedes. You have seen the presentation this morning by Luciano, that has been founded by the INFN, and that will benefit, is still benefit using the quite low noise that is available on the site to install and proof the prototype of Archimedes. So here you can see that at the site, as I said, you have a control room, an optical lab, different stations, several stations underground at different depths, and you have also support from miners for mechanics and masonry service for measurements and for the equipment that you can need directly there. So which are the current activities ongoing? First of all, there are some activities on the surface related to the Archimedes experiment. You have seen what I'm talking about. Archimedes has the idea to measure the interaction between the vacuum fluctuation with the gravity, and is preparing piece by piece the apparatus. And at the moment in the optical lab, the collaboration is testing the prototype of Archimedes. And during the lockdown, there was under commission a multi-purpose control and acquisition system. Here you can see the smart working station just before summer. And it's planned for DAC acquisition, storage system, and an acquisition system that will be used by not seismic probe underground. So is planned to resist and to work directly in the caves in the different stations that you have underground. Last October, we got the first piece of Archimedes, the cryostat of 5 tons. Here you can see some pictures of the arrival of the cryostat, and that has been put in the hangar just nearby the control room. Another activity that is ongoing is the preparation of the underground lab. You have seen in the presentation of Maria, maybe yesterday, that there is that has been already prepared a study to enlarge the cave. What you can see here is the present stage of the cave, Here you can see different section. At the moment you have a cave more or less of 5 meters 8 times 11 meters in one direction and 5 meters in the other direction. You can see here 3 sections of the cave. The study up to now give us a 3D model of the lab. This is the structure that we expect to build underground. Here you can see the final cave with the access point and the shaft. And all the studies about the realization of the underground lab has been completed, and essentially at the moment we are ready to open the call for construction. The other activity is related to the enhancement of the current infrastructure. Always in collaboration with the group of Marcella. You have seen in her talk that they did as well a 3D model of all the structure that you have on the surface in order to optimize the available space. Here, it will be realized a mechanic lab with a 20 tons crane, a clean room, a data storing and management system, and a nitrogen liquefier. In the next months, we'll start as well the connection with a fiber network link. The last line, but not least, is the site characterization and monitoring of the site. The laboratory is giving logistic support to the activity of the characterization for AT. And Sostenatos is just nearby one of the vertex of the triangle. So it's supporting the activity in terms of logistics and manpower. So at the moment, the site is completely monitored by many sensors that are distributed underground and on the surface, as you have seen in yesterday in the talk done by Lucan and many others. New sensors are expected to be installed at the beginning of next year. I mean, geophones, microphones, and magnetometers. At the moment, data are acquired in the control room and transmitted to remote server of INGV, and data are as well accessible through an INFN access point. Here you can see a picture of the measurement station. It's the same picture that you have seen in the presentation done by Luca. You see here there are 3 stations on the ground, 1 on the surface, and additional is not reported in that map, but there are already a few sensors on the surface that are the first seed of the surface array that will be installed the next year. What we got of all these activity is essentially a long-term monitoring of the site. And we already published the first measurements in terms of seismic characterization. And you have seen in the presentation done by Rosario that still the first data obtained in terms of environmental noise are quite promising. So here you can find my conclusion. The lab is a very low noise infrastructure, has been designed to host low seismic noise experiments, cryogenic payloads, and low frequency and cryogenic sensor development. Archimedes is let's say, a use case that will allow to assess the site quality and to verify how to implement underground cryogenics and vacuum systems without degrading the quietness of the site. On the surface, there are preliminary experimental tests to assemble Archimedes component, and the DAC and control system, generic control system, are in commissioning phase. About the underground excavation, all the feasibility study preceding the final design has been completed, and the procedure for contracted construction is going to start. The announcement plan of the surface infrastructure they have seen has been already founded, so we hope that we start at the beginning of next year. As you see, the strong synergy with the IT characterization activities allowed a very detailed monitoring of the noise that you can see on the site. That's all.
Thank you, Domenico. Other questions for Domenico or comments? I have one question. You mentioned that besides the current activities, so the experiment Archimedes that is going on, and all the activities that are going on in Sardinia related to the characterization of the site, there will be room also for other R&D activities. Do you know when this will be possible, or it is already possible to do something there?
Depends on the activities. There are already some requests, and it is already possible to perform some R&D. I mean, there is some room in the underground station to take data. It depends on the R&D you are thinking about.
I don't know, for example, test of suspensions, things like that.
At the moment, not underground. You can do test of suspensions on the surface. Yeah.
And do you have there is a planning about the availability of the underground lab timeline?
So there is an expected timeline, let's say. The expectation is to have the underground lab by the beginning of the 22.
Okay, so more or less 1 year from now.
Yeah, maybe a little bit more, but this should be, I hope, the timescale.
Thank you. Other questions? Okay, if not, let's thank Domenico again, and let's thank all the speakers. We are at the end of the talks of this session, but not yet at the end of the session. We have some time until 6:30, so not negligible amount of time for an open discussion about the topics we have heard about today, and possibly whatever people would like to address. Andreas, would you like to start maybe? Or?
Yeah, I think I can maybe. Well, I say a few comments and some opinions, and then hopefully we can start the discussion. So something that I wanted to add, because maybe it has not been very clear in my talks before, is the scope of the ET design work that we're facing. So we, as I said before, we have updated the conceptual design for the S3 application, but we had agreed that we would not change much in it. So we really just did small tweaks and kept the entire concept the same and tried to have the sensitivity the same. But now for the next phase, there will be a few very interesting questions that we need to answer, and they all relate to cost. I think we've seen it in some talks, especially on the vacuum, where it's a high cost item. R&D topics that would reduce that cost would be game changer for the project. And there are some other items like the shortening the suspensions, which would then allow reducing the cabin heights, which would be a huge cost difference. I think Jan mentioned the correlation between noises in different stations. The amount of that would make a big difference in how much we can use certain techniques in the noise stream, or even other techniques, but with a detector network. So there are key questions, I think, really challenges that will have a big impact, foremost on the ET design, but probably on all 3G detectors. And I think that is some job that we have to do in this instrument science board, to identify them and start working on them, and leading the discussion. So I think it would be interesting to hear some opinions of people. What are, from their point of view, the key challenges that we should address in the coming month in this activity.
Yeah, some of them were mentioned during the talks. For example, one was raised by Jeppo, the silicon versus sapphire choice for the suspension. So then in vacuum, the decision between or among cryo coolers, absorption coolers, or cryogenic liquids. Actually, there are some crucial design decisions to be taken, and this is a really interesting topic, yes. Also to understand when we should take these decisions, because we can take, open the choice probably for some time, but at some point we should go for a baseline design for ET.
Yeah, but on the material for the vacuum tubes, I think there it would be good to start R&D together, probably with CERN and Cosmic Explorer.
Yeah, I think that's probably the most obvious that affects all future detectors in a significant way. So I think that really is something we should do together. Hopefully, we can start from our end to drive this activity a little bit as well.
Ian, please.
Yes, I have another question. So even assuming that FTEs become available from Virgo at some point, or more and more, do we think that the community that we have, including all the new groups that are forming, is enough to do all the work in the end, or how much do we have to still grow to actually make ET happen with 6 interferometers? Have people estimated this already thoroughly, like how to get this done in the end? Because I think if we have to, if we have to grow substantially still, then I think that is something that one would plan early on, because there's not so much time left.
Jan, can I ask to clarify? So how much to grow in order to have enough hands to do afterwards the work in ET, in the installation, or to grow to have a kind of a good chance to get the funding because the community is big enough proportional to the money that we ask for?
I was thinking of the first point about getting the funding. Yeah, maybe that's another aspect which is relevant. But I was more thinking about really getting the R&D and eventually the commissioning and all of that done. Yeah, the manpower or the people power to get everything done. The work, the instrumental work especially. I think the science, of course, is some part that can grow quickly also with people who are loosely associated already with the field, let's say. But the instrumental side, I think, is something that is not so easy to make grow if there's still need for it.
Michele, you raised your hand. You wanted to comment on this, or it was another topic?
In reality, it was on the previous topic, but also I can also address this second one. So about the previous topic, what are the key and the most urgent activities that we want to do? I think from a timeline point of view, are all the activities that have an impact on infrastructure. Because of course, we will have time to adjust the design of the detector until 2030, let's say. Depends what we are discussing about, not the vacuum, because we need to produce the vacuum system before, but some of the details can be adapted at the last moment. But if you wanted to have the infrastructure completed in 2031, 32, we need to excavate and start the process in 2025. And so,
sorry, say it again.
Start the process in 2025. Start the process because I think the call for tender will be a nightmare. So this is a part of the construction. And so the most urgent activities are the one impacting on the infrastructure. And among these activities that are impacting on the infrastructure, there are two kinds of activities, so two kinds of subjects. The one that are under our control, and the others that are not under our complete control. So for the first category, for example, is the height of the caverns. So the height of the caverns is depending on our capability to design suspensions that maybe are shorter with respect to the one that are like Virgo extended to 17 meters. So it's something that if we push hard, we can obtain a result in a shorter time. On the second category, where we haven't the control, is all the political issue on one side versus two, L versus triangle. Here we have to give our input, but then there are external inputs that are money and political decisions that are not completely under our control. So if I have to select a very urgent subject, everything is impacting on infrastructure. Then there are other points. The one of silicon is a clear point. I'm not convinced that Sapphire is the solution, because Kagra is trying to find an alternative to Sapphire. So they have experience with Sapphire and they had a huge amount of problems. But silicon is still not the solution. And so we needed to work to transform a silicon solution. And something, again, is not under our control. If you wanted to produce ingots of 60 centimeters of diameter, they are not in standard or in known industrial producing pipeline. And so we needed to find some foundry that would produce for us that. And I don't know how much it will be difficult. I don't know what is the solution, but we have to invest time, effort, and money in that direction. So answering instead on this point raised by Jan, I think that one key point is what Stefan said. Has been several times said to us that we have to grow also because we need to be large enough to ask all that amount of money. And I think that we have a sign of that this is going on. I mean, the community is growing. The number of persons that are interested to it is growing, coming from high energy physics, but not only. So I think we need more or less to be enough robust. We need to have largely above 10 to the 3 participants to the TIC collaboration. So we need to be 2,000, something like that.
So this is the critical mass, in your opinion?
Sorry?
This is the critical mass to start the reaction.
I think that at the end we need to be large enough. Even if, keep in mind that we are assuming the structure of a project, no? Dividing the project from the collaboration, the participation in the collaboration can have looser constraints and then attract more people. And we have a project that is focused instead on the construction and the realization that is can have a more industrial approach with respect to the typical collaboration approach. So I think that the questions are good, and we need to find our answer to that question.
Yeah, okay. Coming back to one of the points you mentioned, which is, in my opinion, the big elephant in the room. So the L versus triangle issue. I agree with you that not all the implications are under our control or completely under our control, but I think that on this respect, we as a collaboration should give a clear input to the decision makers, let's put it this way. And of course, this choice is going to have a huge impact on the infrastructure, on the design of the detector, on costs. I mean, also on the organization of the experiment. So at some point,
why do you say it's the big elephant in the room? I think
it
is anyway good to do that study and to
absolutely,
arguments.
No, maybe I used the wrong expression. I mean, I think this is a very basic choice to be done. Any opinion on this? Or on the other things that Michele mentioned?
I would just like to make a comment on the growth as well. I think, but maybe I'm biased by my local environment, people I talk to, but what I always find amazing is how quick you can grow. I remember when the original design study was done, we had no project in 2008. And in 2011, people were scared of ET getting all the science funding and their project would be damaged. And I think that shows you how quickly that goes. This kind of grows from where you worry that you don't have enough resources or you don't have enough time to, you're in the thick of it. I think once we get a project going, and what exactly this means is different things at different stages. Now, first, just getting the collaboration organized so that we have a well understood place where people can work in, and then getting some funding nationally for preparing first, and then maybe the EU preparatory funds. I think we will grow very quickly. I think I'm not really so worried about it. It's a big task, so we have to do it well. It's in our hands to create the situation in which we can grow. But I think we are there having some data from the past that this can be done.
So let me make some advertising. So I agree completely with you, and so participate to the session tomorrow morning where we are talking about the ethic organization and how to grow up.
Yeah, Fulvio, I see you want to comment on this?
I wrote in the chat already.
Mm-hmm.
So.
Yeah, Fulvio wrote in the chat in case not everybody's looking. We have to increase as a collaboration, but in a coherent way.
So let me just add one more question into the mix, where it would be nice to have opinions. So even if people don't want to speak up now, I think if you have some opinions, it would be nice to send it to us. So we are now in the instrument science board, at least, very close to starting the actual work, where we're organized enough to have meetings and so on. But of course, we are a collaboration that doesn't work in a vacuum. So a lot of the topics are overlapping with R&D that's going on in other projects, where the people are the same. The meetings we go to might be having 2 sessions. So it would be good for us to again, like Fulvio said, do our work in a coherent way and a constructive interference with other projects. So we, as a next step, will have to discuss how often we meet, in which form, and these kind of things. So if you have ideas and suggestions how work packages and divisions should meet, whether it's all in the open, whether we have small calls, big calls, how often, I think that would be appreciated. We will, of course, discuss it, but some input would be useful. Yeah, indeed. Francesco writes, without spoiling the existing collaboration that will sustain the field. I think that's a key point. I mean, we as ET always said we will only exist if the current projects are a success and will remain a success. But we hope as ET we can also provide the necessary positive outlook for the current projects so that we can cross-benefit. And that has to be done in the right way, also in the practical sense. Like, you don't want to schedule a meeting in parallel to some LIGO Virgo Kara meeting and then have conflicts like we have now, for example, with Lisa. So that is a lot of effort to do well. And we're happy to have suggestions.
I think that, sorry.
If I may follow on what I wrote, there is currently a discussion in Virgo about say dedicated effort that is needed to keep the enterprise running, and we feel on one end that keeping the enterprise running is also contributing to ET, but keeping the enterprise running is also producing scientific results and taking data and so on with the existing apparatus. So Virgo could recognize, because it is its interest to that it is its interest to contribute to ET. But on the other hand, it would be good that the newly forming ET collaboration considers to take into account, in a broad sense, whatever, the work done by people that typically stay longer on the existing detector because they are data analysts, and but taking this into account when these people will join AT. I don't know what I use. What I like to say is that there is some turnover in competencies during these long periods of time. We have designers, builders, commissioners, and data analysts, and they contribute to a project at different moments, but they are all part of the same community. So we must try to make everybody beneficial of this.
Yeah, very good comment. No, I fully agree. Let me just add an anecdote, maybe, just because I found it personally interesting. When we started the advanced detector project, I remember I think it was my first GW-ADW. That's why when Francesco speaks, I think of it, in Elba. And I was at that time working in GEO, and people were pushing the advanced detectors. And I was the one raising the point that we should not forget the current detectors and keep them working. So I'm very aware of that. And I think we could solve that struggle back then a little bit better, because we were doing these advanced detector projects within the same collaboration. Now we have slightly disjunct collaborations, which makes it a bit more challenging. But I think there's enough overlap so that we should be able to talk and sort this regardless. Okay.
Yeah, I would like to highlight one comment of Fulvio in the chat, that is to coherent plan of R&D. I think this is a very key point. Let me say, also, I can tell you my experience. Also in Italy, we have a request by groups to make activities, R&D activities on ET. And I'm trying to address this intention to make R&D for ET in some coherent direction. So avoiding the maximum freedom, but trying to address them on the hottest subjects. I think that is the only way to realize R&D that have a strong impact on the design and the realization of ET. So I really believe that having an international common plan of R&D, that is not meaning that we oblige people to do something that they don't want to do, or forbid people to do in something else, but we should give guidelines, give directions and activities that are very hot, that are needed very soon, in order that in terms of project, we are able to answer to key questions. And so I think this is one of the major duty of the ISB, to identify priorities, critical subjects, and to create a list of priorities in order that to address policymaker at the national level, in order to fund the most urgent activities. Not all can be funded at the same time. We have an expenditure curve, and so we needed to use as much as possible this expenditure curve.
You are referring to a coordination within the ET collaboration, so within the groups that are part of the ET collaboration, but also with external groups, with example, Cosmic Explorer, CAGRA.
I mean, there are common issues and can be, for example, silicon with LIGO, and this can be,
or the vacuum tubes that you mentioned.
Tube can be done in a global scale. Perfect. I mean, it's perfect. But then there are other issues that can be, I mean, prioritized. And I think we need really to work first on that directions. One of that, I said, the suspension design, I think it has a large impact on the design of the infrastructure. So we need an answer as soon as possible. So there are things that need to be planned, and we need to concentrate the effort first on that subject and then move on the others. So, for example, if we are not able to produce, let me make a very stupid example, but maybe wrong. They are not able to produce the most powerful laser at the beginning, doesn't matter. I mean, it's not this is the highest priority because we have time to produce it, but we haven't the time to finalize the infrastructure design. And so the ISB should really identify the high priority in order to focalize funds and human resource on that subjects.
Michele, on this line, if you want to stick, of course, on the plan that we have submitted to ESFRI, then we should be able somehow to have a kind of deadline for defining these critical points. So I think this could help to focalize, as you said, the attention. So we know that within 2020, blah blah, we have to know how to how the isolation system, what kind of isolation system we are going to use, and so we can define the cavern 8 sites. So
I can tell you that according to the ESFRI plan, in the first quarter of 2024, we need what is called sorry for this definition. We are trying to find another one. The pre-preliminary design, essentially the common design for all the two sites.
24, you said.
Sorry?
24.
Yeah, the first quarter of 24, we need the design that is used as input to produce the customized design at the end of 2024. Okay, so this is the deadline. This is for the infrastructure. So what means that in end of 2023, all the question marks impacting on the design of an infrastructure should be more or less solved. Or at least we needed to have taken a decision for 2023.
Yeah. But I think we should really define all this. Well, more or less, we all have in mind what is more critical for the design of the infrastructure. But probably write down all these points could in the direction also that Fulvio was saying, to try to organize the R&D. At least people knows exactly what are the critical R&D, the R&D that are on critical path.
I mean, this is the duty of the ISB.
Yes, that is the first task we have on our list.
Yes,
and we're just waiting to get the word go. So we're a little bit slower than we were hoping to be, because some of the work package organization took a bit more time, but I think that was time well spent in order to do it in a careful and coherent way, so that we are well placed. But I think, as I said before, in 1 or 2 weeks, we can actually have the people officially approved, and then that will be our first task. I think Michele even had it in his slide as a deadline for us.
Mm-hmm.
This is Ettore. I have to go. I'm sorry. I don't know if I was meant to assist to this, to attend to this meeting, because maybe that was restricted. I was elsewhere. I went back and I found still the connection on my computer. So
it's an open discussion.
Okay, it's an open discussion. So sorry, but I didn't know. But these points are all very interesting. I think we must make an urgent effort to focus critical points versus timeline. And of course, the way, as usual, is to fix deadlines and take decision before given deadlines, and then backwards reconstructing what we can do in the meanwhile towards those deadlines. So priorities are not so difficult to be identified, in my very immodest opinion. But about the freedom of research, certainly growing up in a coherent way, it's auspicious of everybody of us, of course. And ruling or restricting the creativity in finding solutions could be an issue. So I think there is a committee, okay, which has got a lot of ideas, experience, is supposed to have experience, and they have to outline the main priorities, and of course being open to collaborations, with other collaborators coming even from other areas. But which are the main lines? It's very, indeed, it's simple. It's not so difficult. Moreover, of course, we might discover something new. That is very bad. Something new which was completely unforeseen for building this detector. And that is something that might turn to be major issue in the future. But outlining the present needs in order to go ahead towards the design, I think it's not that dramatic. It's a matter of energy, okay? Energy, the money and the time we have. And on the other side, there are the specs we want to reach and the experience we have. All these are the ingredients. And of course, I think I'm surprised we don't have, we still have to think about which are the things we have to face more urgently. Of course, to some extent, we have to tell people this is the responsibility of who have the knowledge. We have the responsibility of precisely guiding the collaborators, new collaborators into this big collaboration to provide their efforts and reach the main targets we have. That is a big responsibility. It starts from properly structuring the work breakdown structure of the project, because the mistakes, the sins done at this level will be corrected in 10 or more years. So that is the main step, but that is somehow not the big, it's a big problem, but not dramatic. To that extent, maybe I'm not so clever, but outlining the main problems maybe is not so difficult, and everybody of us know which is, but if every time, which are the problems? If every time we meet an issue and we start saying, yes, that is a solution, but there is also the other, and we know that the other might cover few percentage of success with respect to the previous, that is a political assessment that is not nice and useful in this stage. We must be aware and responsible at this level. Having said that, I don't have other things to say, sorry. I can collaborate anyway, if asked. But I think you all have all the awareness to provide and identify the needs sharply. So I'm sorry, but I have to go. And I don't know if this is useful, but if it serves to condense earlier a plan of priorities, that is my 1 cent contribution to the discussion.
Thank you, Ettore. This is for sure something, I mean, very useful, and everybody is welcome to contribute, as was said many times today by basically all the division chairs. So,
yeah, because for instance, it is clear that people dealing with the present machines are extremely, as Francesco also said correctly, they have the experience. In the end, they have to do things. So those who are deeply involved in present machinery might be too busy to envisage long-term future. But maybe that is not fully true, and they might properly contribute also at any level. I mean, for providing information and improving the stream, the flow for developing.
This is for sure. I mean, in the end, if we want ET to become a reality, we will need a contribution from everybody, even beyond the present community, which designed, built, and is running the gravitational wave detector. So, as somebody pointed out, as Francesco pointed out, we need to do this, taking care of not spoiling the work.
No, it will not be spoiled. It can't be spoiled, of course. I agree with Francesco to that extent. Anyway, we have to do it very soon, I think. And we must, everybody of this collaboration must know that there is a very, very urgent matter. For instance, we are talking about cryogenics. Let me say, since 10 years ago, we depicted cryogenics for low frequency detector, but is that feasible? Okay, under what conditions? Is the suspension something which resemble roughly what we have presently or not, in order to have also cryogenics there? I think not. It is something new. The problem of CAGRA that made in parallel in order to be faster, cryogenics and suspension, and put together them was, of course, a successful enterprise, but a lot of problems arose from there, you know, because in order to be faster, they piled up things together. Even though they had a long experience in cryogenics, that was finally spoiled. What it means that you cannot put together room temperature and cryogenics simply by adding them, okay? Because the test mass becomes not only a test mass, which is in a quasi-inertial state, and also which is an element of an interferometer, but it is also a tool for cooling down. So completely different object, understand? So these things are already on the table. We must succeed in properly identifying soon the priorities.
Michele raised his hand.
Yeah, I would like to go back on your comment, Gianluca, because you triggered me something.
Which comment?
The comment about the international or not only T but beyond T. I think one of the input that the steering committee could receive from the ISB is also a list of subjects where we can collaborate to somebody and the list of somebody. I make an example about the silicon substrates. I think we really need to form an international committee composed by T and Cosmic Explorer, and we need really to try to make first an industrial search to understand who can work with us, or to see if at the level of academic laboratory there is somebody that can work with us on that. And of course, if this request arrives just from IT has a certain level of strength, it arrives also from Cosmic Explorer as another level of strength. And so I suppose there are 2 or 3 subjects like that. There is a vacuum, of course, but this is already is finding its path. We saw the very interesting presentation by Paolo Piggiato. I think here we have a direction where to really make some improvements with collaborating with CERN. But if we needed to produce a 60 centimeter diameter silicon mass, at the moment the limit is 450 in the industrial production. So we need to understand who is able to collaborate with us. And this is a common, is a global activity, but there are others like that. Maybe we need a short list to negotiate in activity. I mean, 450 is what we have. No, in reality, we have 2 options, if I'm not wrong, in the last design is 57, sorry, 570, and or 450 because is what the market is able to give. Andreas, you can correct me, but in the last document I just read a couple of hours ago, this. I'm commenting, Stefan.
Stefan wrote a comment in the chat. 450 is what we have in the T design, not 600 millimeter.
But it's not true. At least what I read very few hours ago is I'm looking to the document.
Okay. Okay, so the session is coming to an end. I just wanted to mention another point that came up several times today. It was mentioned several times in several forums during the talks today, which is the point of interfaces. So I think that one of the major tasks of the ISB will be the definition and the taking care correctly of the many interfaces that there are among the various divisions and working packages. This was mentioned today, maybe several times by Alessandro. Of course, the suspension and cryogenic system, of course, vacuum and cryogenic have many interfaces with the other subsystems. The infrastructure division have basically, it's a giant interface with the other detectors. So, of course, the organization of the ISB is divided in divisions and work packages within each division, but we definitely need to think of the detector as a whole system, and one of the major tasks of the ISB will be the correct handling of the interface. Identification and correct handling of the interfaces. And we need to do this soon, because we cannot arrive at a later stage of the design and then discover that we forgot or overlooked some critical interface. And from this point of view, I quite agree, I must say, with Ettore. So probably the design of the cryogenic payload requires, we cannot just adapt what we currently have in the present detectors and adding the cryogenic system on top. We should start designing from the beginning a new system. So there is a discussion going on in the chat. I don't know if you want to summarize it, so I don't have to read it.
I can quickly summarize. So the high frequency detector has 62 centimeters diameter and 30 centimeter thickness. So that's this optimal ratio of thickness being the radius. And that is driven by the beam size to get kind of the coating noise down and the radiation pressure, but that's kind of the secondary one, and that gives you the 200 kilograms. And then for radiation pressure, we felt we have to give it the same weight, at least for the low frequency detector. Their coating noise is less of a problem because we assume you gain by cooling down. But the radiation pressure is still there. So then in the original design study, we used the 45 centimeter. We optimistically hope we would get, and that still needs to be seen whether you get something like this in the right quality. But I think we are closer to that than to 600 millimeters. And then the assumption was, okay, because ingots, the length is not the problem. In order to pimp it to the 200 kilograms, you then make the length a little bit longer. So you have a different aspect ratio. It's 45 centimeters diameter and 57 centimeter length.
Yeah, but the diameter of 450, I think, is something that we imposed because it's the limit of technology of 12 inches.
Yes. If we would get 600 millimeters, that would be nice. Yeah, of course.
So we imposed the design by the existing technology.
To a certain extent, yes, which is not a bad starting point at many points, or?
Luciano, I see that you have your microphone open. Do you want to? No. Okay. If there are no more comments or questions, it was a long day, very interesting day, in my opinion. At some point, there were more than 140 participants in the session. Now we are more than 60, so I think.
Yeah, keep in mind that there is also YouTube, but
and there is also YouTube. Yeah,
on YouTube usually we have 80, 100, 150 persons, so it's impressive.
So very good. Let me, before closing the session, let me share my screen just for 1 minute. I would like to remind everybody that tomorrow the symposium will continue. Tomorrow morning at 9 o'clock, there will be a session dedicated to the organization of the collaboration, the introduction, and then 1 hour, more than 1 hour discussion about the organization of the ET collaboration. And then at 11:15, the instrument science session will continue with several talks, some of them in the morning, and then at 3 o'clock p.m. there will be the last part of the instrument science session. So thank you everybody for being here today. It was a very interesting day, very interesting talks, and very interesting discussion. And see you tomorrow. Bye-bye.
Bye-bye. Goodbye.
Thank you. Bye-bye.
Bye.
Bye.